Okay, we're now going to do infinite limits algebraically. And so these problems are very easy if you relax and listen to the video and follow the steps. We've already done infinite limits which occur at vertical asymptotes. Think back to Limits Worksheet 1, where you could get a positive infinity, negative infinity, or you have both positive infinity or negative first and positive second, or both negative, or a positive mixed with a jump, or a jump mixed with a negative, or something like that. Those are all called infinite, vertical, or unbounded. We also found these on worksheets 2 through 4 when we did tables. And when you did your table, you made a nice table and you could see negative infinity, positive infinity, so D and E. Sometimes you got the same infinity. And so in this case, we got the same infinity and it was negative infinity. Now let's consider these two basic one-sided limits right here. And when I look at this one-side limit and I'm dividing, this means by a number very, very, very close to 0, but not actually equal to 0, as you can see, but it's positive. It just keeps increasing, and is unbounded. And the closer you get to 0, the closer you're heading to some number that does not exist out there in positive infinity land. When I go approach 0 from a negative, and again, this could be any number, 20, 30, 1.6, whatever you put, you're just going to trade the 1 with. And you can see that this is heading towards Satan. You are heading towards negative infinity, and the closer you get to 0, even though you're a negative number, the closer you race down towards hell. Now, common sense should tell you that when you take a quantity and divide it by a very small quantity, you always get a larger quantity. Check it out on your calculator. 30 divided by 0.01 would give you 3,000. 12 divided by 2,000 is going to give you 6,000. And so this all should make some sense. Now, let's not lose sight of the fact that negative infinity and positive infinity are not real numbers. Hence, this means D and E. But we only use D and E when these behaviors descriptors from the left and the right are not identical. So now I am going to create some useful notation for you. We already know that when you take a non-zero number and divide it by something very close to 0, our answer is positive infinity or negative infinity. Hence, 0 with a little plus in the exponent will not just mean, it will mean you're approaching 0 from the right, but it's also going to mean you're a very, very, very small number, just for emphasis. And we're already used to using this notation 0 from the left, but now when we think of it, we're going to think of a very, very small negative number as we do the problems. So this all translates into some very convenient thinking. A positive number, any positive, no matter how small, 0.000000001, when you get divide by something that's even closer to 0, will be positive over positive will be positive infinity. No matter how small this positive number is, you can make this number even smaller, and you're going to end up with positive over negative is negative infinity. Now, negative over 0 positive, negative over positive will be negative infinity. Negative over negative will be positive infinity. You learned those rules in 6th grade. Continue to use them. Again, I will emphasize these descriptors just indicate the behavior. Remember, these limits really are D and E because they are not real numbers. Now let's look at some examples. So for my first example, the first few that I do are straight off your little packet that you'll have a digital printout of that you had it already. When I say I'm going to plug in, the first thing I did was simply plug in the 9. And I have 1 over 0. The second thing I do is say, well, what number's a little left? 8.9. Well, 8.9 minus 9 is a negative. And then the third thing I tell myself is positive over negative is negative. So for the next one, it says 9 from the right. The first thing I do is substitute in the 9. 1 over 0. Now the second thing I do is say 9.1. 9.1 minus 9 gives me a positive. So notice I don't get 0 negative or 0 positive immediately. I get the 0, then I determine the negative or positive. These are not equal, so it's D and E. And it's a vertical asymptote, it's infinite, it's unbounded. So let's look at this next one. I'm going to ask the limit as I approach 9 from the left. So first I plug in 9 and get 1 over 0. Then I say, well, the left is 8.9. And 8.9 minus 9 is a negative. Now, I never show this step. I do it in my head. What is a negative squared? It's always a positive. The minute I see this, I know it's positive. I don't need to do that, and I get positive infinity. I do this one likewise. I plug in the 9, 1 over 0. I say 9.1. Well, 9.1 is a positive. And a positive squared is always 0 positive, and these infinities match. So I'm positive infinity, and we have a vertical asymptote, infinite unbounded. For the next problem, I'm going to have us approach 2. So approaching 2, I first plug it in, 5 over 0. And now I say from the left, 1.9 gives me 2 minus 1.9 is a positive. So positive over positive is positive infinity. Then I insert something a little bigger than 2. 2 minus 2.1 would be a negative number, 0 negative. And positive over negative is negative infinity. The infinities don't match, so it's D and E. And yes, these will always end up vertical asymptotes. Going to the next question, approaching 2. So the first thing I do is insert the 2. I have 5 over 0. So I say from the left, 1.9 from 2 is going to be a positive number. And a positive squared is positive, and positive over positive is positive infinity. I'm now going to do something a little larger. And so when I insert the 2.1, I have a negative. But what is a negative when I square it? It's a positive. These are both positive infinity. My final answer is positive infinity. And yes, I have a vertical asymptote. Always. Okay, that's what these problems are like. And so let me continue on. Sorry, I'm dragging my cord. My phone won't keep charge. Okay, so now let's go to the next one. I insert my negative 2. I have negative 5 over 0. Step 2, a little left, and I get 0 but negative. Negative over negative is positive infinity. A little right, negative 1.9 gives me a positive, so now I can put a plus on there. And negative over positive is negative. The infinities don't agree. So the overall limit is D and E and a vertical asymptote. Problem 6. I'm going to use negative 6. I first insert negative 6 and get negative 6 over 0. Step 2, by the way, you can put that down twice. To the left, negative 6.1. Up here, oh, that's a negative number. Negative over negative is positive. Now I try negative 5.9. Oh, that's smaller, so it's a positive. Negative over positive is negative. They don't agree, so D and E. Next problem, I'm going to do 6. I insert my 6, 6 over 0. Notice I wrote it twice. Step 2, a little left is 5.9. Ooh, makes it negative. Positive over negative is negative. 6.1. Ooh, makes it positive. Positive over positive is positive. They're different, so the answer is D and E. Number 8, I'm going to come along. Negative 4. I get negative 20 over 0, step 1, so I can write negative 20 over 0 twice. I insert negative 4.1. Well, when I square 4.1, it's bigger than 16, so that's going to be smaller, a negative. Negative over negative is positive. 3.9 is smaller than 4, so when squared is smaller than 16, and 16 minus something smaller is positive. Negative over positive is negative. These two do not agree, so the answer is D and E. One last problem where we make you do all the parts. I'm going to use -4. Notice 16 times 5 is 80, and 16 minus 16 is 0. Step 1. So I put 80 over 0 and 80 over 0. Step 2, a little left. When I square this, it's bigger than 16, and 16 minus something larger is negative. Positive over negative is negative infinity. Negative 3.9. Well, 3.9 is smaller than 4, and when I square 3.9, it'll be smaller than 16. 16 minus something smaller is positive. Positive over positive is positive infinity. And so the final result's D and E. The rest of the examples will be a mixture of x approaches A, from the left, from the right, or just approaches A. Some of these will be gotchas. So, first example, simple. I just want to know what happens on the left. I insert 3 and got 1 over 0. Now, 2.9 is smaller, so it's negative. Positive over negative is negative infinity. Next one, I'm just considering the right side. First, I plug in -1. -2 over 0. At this point, I could have stopped and not done all of this work because that's a square. And a 0 squared, whether it was really a negative number or a positive number, is always going to be a positive. So -2 over 0 positive yields negative infinity. Next example. 4 from the right, I get 6 over 0. Testing 4.1, oh no, it makes a negative number. 0 negative, positive over negative is negative infinity. Moving on, next number. Plug in 3, I get 9 over 0. Do you see that square? So plus or minus, when I square it, will always be positive. I don't have to even go here or here. I can just say 9 over 0 positive and get positive infinity. Now, the next group of problems are going to be best done by factor reduce. It is so much more work to do if you don't do the factor reduce step. Although it's not technically necessary, since these will not be 0 over 0 indeterminates. So, I will start with one that's in your packet, and you probably would not factor and reduce, but your pencil might not help itself. It just has to do it. In this case, I plug in my 3 and get 6 over 0. 2.9, when I square it's smaller than 9, so I get a negative. I'm done. But notice, if I couldn't help myself, I could have factored the x squared minus 9, canceled. Now I have 1 over x minus 3, and I don't have to think at all. 2.9 minus 3 is a negative. 1 over negative infinity is still negative infinity. Now for the next grouping, I'm going to show them both ways, where you factor and reduce. It doesn't matter, no matter which way you do it. And please do not tell me you can't. Oh, but I did it this way because I tested a number like 2.1 and I did all this arithmetic with my calculator. I don't want to hear it. Thank you very much. When you have two x terms in your denominator, you have to factor. There is no other choice. But now notice this is conveniently made where it factors and reduces. Negative 5.1 makes the denominator negative. Positive over negative, negative infinity. Very easy. Over here, oh well, I have an x squared and an x. I must factor. Oh, you can do it for fun, get no credit. Lose 5 points on a test every time you have a problem like this. Okay with me, and I know it'll be okay with Mr. Capps. So I factor, but I didn't reduce. No big deal. I plug in step 1. Remember, we don't use this, just plug it in. I get -9, -9, and 0. So I have -9, -9, and 0. Now I try negative 5.1 and I plug it in. Ooh, negative 5.1 makes the 0 part negative. So this is really negative times negative, and negative times negative is positive, and negative over positive is negative infinity. Now, that's doable, and we will have to do it in some problems where we cannot factor and reduce, but that's not on this worksheet. They will all work so nicely like this for day 1. Wait for day 2 or day 3 to get to these suckers. All right, now let's try another one. Again, Mrs. Simpson has nicely factored this one because I looked at this and I want to plug in and I see 16 and I go through positive 4, negative 20. That's going to be a 0 in the denominator, but I can't figure out if it's 0 negative or 0 positive. There's no way around it, so I must factor. Notice these two add together and give you 0, so they're inverses. So, because when you have opposites and they add and give you 0, you know when you divide them, you get negative 1. So I now plugged in again, and I had 1 over 0, negative 1 over 0. Now I say, was that 0 negative number or a positive number? And negative 4.1 makes it a negative. And negative over negative makes our answer positive infinity. Okay, I could have chosen just to factor but not reduce. Remember, it is not optional. You must always factor and you must always factor when you have 2 x variables in your denominator. So I factored, but I didn't reduce. I just did step 1. All that's going to end up when I plug in negative 4. That should be a positive 9. I screwed up. Sorry. Positive 9. Okay, so that's positive 9. And now in the denominator, it's negative 9. And so this answer is going to change. Don't worry. We'll fix it. And so now when I plug in the negative 4.1, after I've got all my answers, I'm going to see, ooh, that's really a negative. Negative times negative is positive. And remember, that was 9. And so this is positive infinity, and this is positive infinity. Yes, an error corrected. Okay, now for the rest of the examples, many professors will ask you to obtain a common denominator. But for us, this is excessive work because we are not going to do any proving. So we just want to get to the answer. So notice step 1, I inserted my zeros, and I get 0, and positive over negative is a negative infinity, and 0 plus negative infinity is the same as 0 with minus infinity. And guys, no matter what you add to negative infinity, it's going to stay negative infinity. I don't care if you add a trillion, 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 trillion times each other forever, or a trillion to the trillionth power. Plus negative infinity will be negative infinity. It's humongous. So now let's do the next problem the way the professor would want. See, I just said, oh, he needs an x, 5x squared over there. I insert my numbers, 4 over 0, negative. I still get negative infinity. All right. So let's do it the way I suggest for the second problem. And so I insert my zeros, and so I get a 0, and I can see, ooh, a negative and a negative is positive, or I can say 0 minus, and that's negative infinity. It's still a positive. It's still positive infinity. Or I can get the common denominator, and this will become negative 4x cubed minus 7 over x. Negative 7 over 0 minus negative over negative is positive infinity. And now you can do your worksheet.